What's up everybody, this is Garrett Industrial. Today I am doing an electrical call out. This is a lovely residential home, so we'll be working in the residential applications. And I just had an idea. Since I have my own company, I am a licensed journeyman, I do have an electrical C10. I kind of figured that I would start taking you guys into my world as an electrician. That way, if you guys are a student, you guys can kind of see how the actual physical application is, or whether you guys just want to learn on your own. This is a great way for me to teach you. That way we can learn together. So the first thing I'm gonna show you guys how to do today is just simple. I figured this would be a good way for us to get to know each other, as well as for you guys to get a basic intro on electrical. First thing you guys want to do, no matter what it is in any electrical application, if the circuit does not have to be energized, go flip the breaker off. A lot of times we get too comfortable and too fast paced, and we want to just do everything live so that we don't have to turn anything off. But that's not how we work safe, okay? And the problem with not working safe as electricians is if I'm not working safe, then I'm not keeping everybody in this residential house safe, right? And I'm also not keeping myself safe, and we want to go back to our families at the end of the day. So always make sure that you turn everything off when applicable. In hospitals and certain areas where you have continuous loads, I know that you cannot turn stuff off. If you can de-energize, go ahead and de-energize. So what we have today is a basic duplex receptacle, and this is a common problem. You see how the receptacle is shattered? That means that anytime we go to plug something in, we potentially have that spot for an arc, right? Or a short, because we have this bare copper exposed. And most of the time in your residential applications, your boxes on the inside aren't going to be metal, but for some reason they actually do have a metal inside box. When you energize this receptacle, all the screws on the outside are also hot, right? So anything that the hot conductor is touching now becomes live. So that being these screws right here also become live. If this is broken, I now have a larger area, a margin for an arc or a short or a ground fault, any kind of fault. What happens if your toddler walks by, or a baby walks by, or even an adult? What happens if you walk by and now you accidentally touch that live metal piece, right? I'm gonna show you how to do this safely, how to replace it, and if you have any questions, feel free to leave them in the comments. You always want to make sure that you are de-energized, right? So I already went and shut the breaker off. In order to test, I'm gonna take my multimeter, which is this voltage meter right here. It's a Klein. This is normally what we would use out in the field, and I'm going to make sure that we don't have voltage. I am checking for AC voltage because I know that our circuit is also using AC voltage, right? When deciding how to use what button on your meter, this is gonna be your AC current. It also has DC current on there. This is gonna be to check for amperage. This is gonna be to check for continuity. Everybody likes to call it the Wi-Fi symbol. Showing you guys that. And it's real basic. It's just to let you know that if you are on DC current or DC voltage, right, and you're checking for AC voltage, you're not going to be able to read the voltage because your meter is in DC mode. So if you know that you have AC voltage, you want to make sure that you're using AC on your meter as well, right? So I'm on AC. So there's two ways you guys can do this. You guys can either you guys can go right through the front, and that's normally the way to do it. It's to stick your leads right through the front like this. See, we're falling apart. That's how bad this is. I know I don't got no voltage. If this is wired correctly and it's not falling apart all nasty like how we have it, so you take one lead and you would put one lead on your hot conductor. So I know that my current carrying conductor is black, right? And you would take your other lead and find any source of ground that you can get. That way you can measure to see if you are live. For some reason, they didn't add the ground wire to the receptacle. It is grounded in the back of the box since this is a metal box. And when I do so, if you check the screen, I have underneath 1 volt. That's 0.692. So I am clear to work, and we're gonna go ahead and get started. Now that my broken receptacle is all the way off, we are going to install our new receptacle. On the back of this receptacle, it'll say hot side. It'll also say white or blanco, and that's just to show you which side is your hot and which side is your neutral, right? Now, if I already know that this is my hot side, I know that that is going to go to the hot side of my outlet, right? Another good way to remember this by is your neutral side is always going to be on the same side as your ground screw. Now, for some reason, they don't have any ground wire in here coming out, which is dangerous in itself. Always ground your devices, because when the code inspector comes, if he sees that your devices aren't grounded, that's a potential fail, right? So we always ground our devices just like we always ground our metal boxes. I don't know why they don't have grounding conductor. We're just gonna go ahead and install this. So if you take a look at this particular duplex, it actually has the clamps And I like these better because now you don't have to wrap your wire around the pole. And also too, what you can pay attention to is on the hot side, normally your screw is going to be a gold color, and for your neutral side, your screw is going to be a silver color. I am going to insert the wire, and these little clamps can be kind of tricky, okay? So you want to make sure that you're installing the wire where the clamp can hold onto it. That way when you actually go to tighten it down, we don't come loose. And we don't want any chance for a short, right? So we want to make sure that we're getting a good solid connection. And tighten your hot down and give it a tug test just to make sure it's not going to come off. I just connected the hot side of my device. Now the proper way to do this is to install your ground first on your device, and then your neutral second, and then add your hot conductor last. Normally I know that we would do the ground first and then the neutral and then the hot, because that's the proper tie-up. I am going to install my neutral on the neutral side. You want to make sure that you're actually getting on the clamp so that the wire is being held by the clamp. And then you go ahead and tighten that down. After you have installed your hot and your neutral to the device, I always give it a tug test. And what I mean by that is you grab your conductor and you just give it a pull, okay? You want to make sure that these conductors are not going to come out. Okay, so one more quick thing that I would like to discuss with you guys before we do our finish work, okay? So let's talk about parallel and series for a second. Now, if this device was wired in parallel, then if the other devices on the circuit go out, this device would still be on, right? That's parallel. It's easier to troubleshoot in parallel because we know that if that specific device went out, then that's the problem. However, if it was in series, it's a little bit harder to troubleshoot because now you gotta open all the devices up and find the fault in all of the devices, right? Because in series, if one outlet goes out in series, then they all go out. It's a little bit harder to troubleshoot. And now let's get into the actual wiring of parallel and series circuits, okay? So this outlet right here, there's no pigtail here, okay? This is my main hot coming from the home run. I would pigtail to the main hot wire and then add a jumper over to the connection. Same thing on the neutral side. But since there's no pigtail and it lands straight to the device, we are now in what's known as series. So when this device fails, all the other devices are going to show a fail, even if they're not a fail. If 3 lights are in series and we're feeding 120 to all 3 lights, there's 3 devices in 120, you are going to divide 120 by 3, right? And that's going to be, each device would end up getting 40 volts, right? So we don't normally wire in series unless you're trying to protect all the other devices on purpose. So now let's get into our finish work. So everything that a hot conductor or even a neutral conductor touches becomes energized, right? If it's a conductive metal. And what I mean by that is these screws, as soon as this device turns on, these screws are going to be live. So if I know that my box in here is metal and this screw is also metal, then I have a high chance of having some sort of short, right? Or some sort of fault. So what I'm about to show you guys isn't specifically code, although I would argue that it should be code. To tape my 33 tape, electrical tape, you can use 33 for anything, by the way. This is the best tape on the whole planet. I recommend it for whatever taping job you need. 33 will do the job. I tape around the device so that when I push it back into the box, none of these screws or none of these conductors are able to touch the metal box. We're gonna take our outlet, fold it back into the box. We're gonna make sure that both of our screws are in place. So we're gonna start tightening. And what I want you guys to pay attention to, the most important part of finish work, the absolute most important part of finish work is making sure that the outlet is straight, okay? You don't want a sideways outlet. Number one, it looks ugly and unprofessional. And number two, those screws on the inside are hot. Now I know that we taped it, but in the event that you did not tape it, if you're sideways or crooked, your outlet could possibly touch the metal box, right? So we're gonna go ahead and finish her up. Make sure she is good and snug. Do the same for the bottom screw. Nice and snug, nice and straight. Okay, we are good to go. So now the last thing that you gotta do before we check voltage, put the cover back on. Or these are also called finish plates. Now they're super easy. All you do is you put them over the outlet like that. And if you have a straight outlet, they'll go right through the 2 holes and it'll be perfectly lined up in the middle. You just install this screw and this will hold your plate on, okay? So this is the easiest part of the whole job, is this plate. Trick to these is to make them snug, but not super duper tight. So once I start to feel that it's already tight like that, good to go. Make sure that we're all straight. So now we're gonna go turn on power and we're gonna make sure that we're getting 120 volts. All that, I went and flipped my breaker back on. We are gonna check voltage and we're gonna make sure that the circuit, meaning the device, is actually wired the right way. So this is what's known as a circuit tester. So this is pretty great. This tells you if you have an open ground, if you have an open neutral and open hot, if you have a hot and ground reversed, or if you have the device wired correct. And what it does is these lights will turn on based on what configuration you have on the device, right? So if I have an open ground, I'll only get one orange light in the middle. Now, if I did the outlet correct, I'll get two orange lights side by side. So let's plug in our circuit tester and see if we did the outlet correct. Okay, so as you guys can see, very clear, we have two orange lights, meaning that our outlet, the device, is actually wired properly. Check for next is voltage. Okay, so you want to see 120. Now sometimes you do get a little bit of voltage drop, so if you get anywhere from 118 to 116, don't freak out, it's okay. What you don't want to see is over voltage, right? So we don't want to see, for some reason, 208, 180, 190. Okay, we don't want any extra over voltage. So we're going to take our multimeter once again, AC voltage, how we had it the first time. We're going to turn our light on so that you guys can see. And we are going to stick our two leads right into the front of the duplex receptacle. Okay, so I am getting 121.3, which is a good solid connection. A little bit high, but not too high to where I feel like it's gonna be a problem, right? So 121 volts, that's what we want. Now you go ahead and check the bottom, just in case. 121.4. All right, cool. So you guys have now learned how to troubleshoot a little bit, how to wire up a receptacle, how to take apart a receptacle, how to do the finished work behind a receptacle. I hope you guys enjoyed this video. Like I said, I will be taking you on all of my adventures through my company, so you guys get to learn and so that I get to teach you how to become an electrician, okay? Like I said, I do residential, I do commercial, I also do industrial, I also do solar. If you have any questions or you need a quote, I will put my contact info in the description and you guys can go ahead and give me a call. I can quote you guys. I hope you guys enjoyed the video and I will see you next time.